Sure did. Is this working? Hello? Nope. Sure isn't. Should have tested this beforehand. Hello? Can you guys hear me? Is that on? Okay, great. Thanks for the introduction. Due to the subject matter, Git Essentials, I'm going to be using the console fairly regularly. I also, because of the number of questions that are likely to be asked, will not be taking questions during the presentation. I'd like to get through it all, but with respect to Jen, who presents in here after, if you have any questions, we'll take them quick. If you have any remaining questions after the time period, you know, I suggest write them down, whatever, and I'll take them in the back. You're welcome. I know, right? I already had the introduction. If you forget my name, you want to call me by name, just ask yourself who locked the bar, the Barlocker, you know. This one? Hello. Yeah, that's, does that, no, it's a directional mic, and it's falling back. Is any better? Still just as bad? All right, what if I just hold it for just a little while? So, right here? How about now? Good? Great. So I'm going to be using the terminal a lot here, and that's how we're going to start. Instead of teaching a lot of theory, let's go create a repository. Can anyone not see this? If I start typing, no, anybody not see it? Great. So creating Git repositories is extremely simple. You can create one on the fly for whatever reason. All you're going to do is create a new directory, go into the directory, and then run a command git init. Ta-da! You have a repository. This is a fully functional Git repository. It will handle committing, branching, cherry picking, pushing, pulling. It'll do everything that you want, and it was that simple. I frequently use Git repositories for code competitions, for just presentations, or any other thing that I want to track and have versioned files for. It's very simple. When I create the Git repository, it's going to do a couple things for me. No, mainly just one, I'm sorry. I take it back. One thing, it's going to create this .git directory. Inside of the .git is everything that Git requires to maintain your commits, your branches, tags, maintain everything about that repository. That only exists, unlike Subversion, which has a .svn directory in every subdirectory of that repository. It only exists in Git in the top level directory. If I want to commit now that I have this repository, we have to talk about staging first. In Git, there is a concept of a staging area, an area ready to be committed. So I'm going to create a few files here, just with a couple UUIDs in them. By creating the file, I've done nothing with respect to Git. I have not added them to the staging area. I have not committed them. They're just files that exist in the directory. If I show the files, there they are. If I cat the contents of the files, there they are. Nothing special about them yet. There's a command in Git called git status. This is going to show me a couple things. It will show me the changes ready to be committed, the staged area. It will show me changed files, ones that are being tracked currently. They've been committed before. They're not new files, and they've been modified since the last commit. In addition, it will also show me the untracked files, files that have never been committed before. Currently, that's the only kind we have. As you watch this next little part, you will notice parts, files in each of the three sections. To add something to the staging area, we're going to use add, git add, and then give it the name of the file or files. If I do another git status, we're going to see that A and C, That coloring is bad. Can anyone not see the coloring? Great. One person, I think we can not change the, oh, maybe. Maybe one more. There, it's gradual. There we go. Yeah, way better. We can see A and C are now ready to be committed. They are in the staged area. If and when I do a commit, A and C will be committed, B and D will not be committed. They will remain untracked files. So here I go. Every git commit requires a message. It can be whatever you like. I commit it. Now if I do another git status, we're going to see that A and C are gone from the status altogether. There are no changes. They're not new files. Therefore, they're removed. They're not displayed on git status. B and D, however, remain untracked. Let's go in and change A. Git status will now show it's a modified file. It has been changed, it has been committed before and it has been changed since. I'm going to git add B and A. This should give us two files in the staged area. One is a modified file, another one is a new file, and then D remains untracked. I can commit again. And now D is the lone file that has not been committed. We're going to just commit him real quick. Now, my Git repository, the working directory, is entirely free from changes. It is clean. Couple things to note. Git repos can be created anywhere. I strongly urge you, anytime you want to version anything, use a Git repo. You don't have to share them. You don't have to start it on GitHub. You don't have to have a company repository to do it. You just make one. It's good. You can commit. Another thing, only the staging area is committed. We talked about that. And then the final thing that I failed to show you until this point is that every commit we do has an MD5 hash that is generated by Git. To show you those, there they are. This commit, if I can find the mouse, oh, there it is. When I committed D, I got that commit ID. It was assigned. I can refer to that commit by this substring of the MD5 hash or by the entire MD5 hash. Every commit that you do has a commit ID. We will refer to these in the future. For now, just know that they exist and they are unique within a Git repository. The commit graph, as of right now, looks something like this. We started a repository, we had an initial commit, and then we made a set of subsequent commits after that. They were all linear, there was no branching, no merging. It's very simple so far. You can see every commit has a commit ID. Now let's take a look at what just happened from Git's perspective. There's a command called git log, very similar to subversion log, if you're familiar, svn log. It's just going to show me every commit, most recent first, that has happened on the repository, on my current branch, on the working directory. Gives me the commit ID, who did it, when they did it, and the message. I can also view what files were changed. I'm going to go down a few lines so it's easier to do to separate. To do this, I'm going to use git log -- name - status. This will give me every file name and the status of the file in that commit. So some files were added, denoted by A, some were modified, M, some were deleted, D, but we don't have any of those. This is helpful if you know that a file was changed, but you don't know which of the changes were affected, which of the change it is that you're looking for, and you want to find that commit. You can do git log -- name status, and then search for the file, and it will show you all the times that file has been modified. Quite helpful. I'm sorry, let me show you one other thing here. If you remember right, we have a linear set of commits. If I do a graph log combined with a one-line commit message, each commit is a single line, and this is very uninteresting right now, but I wanted to show it on a clean commit. I'm sorry, on a linear set of commits. In short order, we will show the same command on a set of merges and branches. It'll be very different. This can help you debug any merging or branching issues that you've had. Git diff is also helpful in finding what's going to be committed, what was committed, what you're about to commit. It will show you the line-by-line changes as opposed to the file-by-file changes. So let's edit a file. If I should do git status, we see that file was modified, but it doesn't tell us what the modifications were. Git diff will. In addition to that, we can show differences between entire commits. Git diff is also the helper for this. So if I take two commits and I want to find out the differences between them, I'm going to hand it one commit ID, ... another commit ID. This will show me the changes starting at the first commit all the way until the second commit. I would expect whatever I did in whatever to show up here. Turns out we have a new file called D, and it has these contents. So git diff is useful in finding line-by-line changes. Now let's say I had a bad commit. This commit right now, or this FFFF whatever change that I put in, let's say I accidentally committed it. I have two options. The first option is to revert the commit. A revert undoes, sorry, let me rephrase, a revert commits the opposite commit. If I added a line, it will delete a line. If I add a file, it'll delete a file. If I delete something, it will add it. It will do the exact opposite, and it will preserve the history. Let's see, I have the commit ID, so I'm going to revert that commit. Every revert requires a message, though it doesn't take it on the command line, so it's asking me for what the message is. I'm just going to say, keep your revert whoops default. Now if I look at a git log, I'm going to see that the second to last commit was whoops. The last commit was revert whoops. So reverting helps you preserve the history of what has been reverted. Now, if I want whoops back, I have to revert the revert. It gets obnoxious, but at least you can do that. The other alternative in a bad commit is to reset. So resetting is very dangerous. You lose the history altogether. I'm going to reset those two changes. After I do them, those two changes will be gone forever. It's as if they never existed. We're going to do a hard reset is what it's called. And I'm going to reset to this point in the repository's life. So when I do this, the last log message will be whatever. You'll notice that whoops and revert whoops are both gone. They never existed. Be careful, very careful with this command. So to summarize, git revert keeps the history, commits the opposite, whereas git reset hard will delete it altogether from the repository. Next, tagging, branching, and switching between, or checkout. To understand these, we're going to do a couple things. Talk about head is one of them. Head in all caps is a special pointer. Tags and branches are all pointers to commits. Head is a special one that denotes the current working directory. As my current working directory changes as I switch branches or go to a tag, head will also change. Everything happens on head. If I commit, I'm committing on head because it's the working directory. If I switch branches, I switch to head. If I merge, I'm going to merge into the thing that head is. This will become very clear as I actually do it. And then a quick plug for branches, because branches are awesome. In Subversion, if you've ever done branching, it's awful. It's a one-for-one copy of an entire directory to another spot. It takes forever. It's awful. Branching in Git is not that way. Very simple. Use them everywhere, and we'll show some examples of branching. So first, I've got log up there. If I want to go back in history, back in time, and say this was a release. This has happened to me before. We wanted to release something, but we didn't know which commit it would be until, after I've committed some more stuff. So I can do a git checkout. This is going to change the working directory to be whatever I hand it. And I'm going to give it this commit ID, more stuff. I'm going to check out that. Now, whatever happened in whatever, which was the addition of D, will now not have happened in my current directory. D is absent altogether. In my git log, it's not even present. It is present in the repository though, and we will go back to it. But adding a tag is just adding a pointer. It's done by giving git tag a set of properties here and a message. What happened there? Oh, git add, silly me. Git tag. I now have a tag. A tag is just a pointer to a commit. That's all it is. There's nothing special about it. It's just pointing to commit whatever that commit ID was. If I do git tag, it will list all my tags. And now I can actually check those out. I can go to a tag. Because a tag is just a pointer to a commit, and because I can check out a commit, I can check out a tag. I can also do branches. One branch, the default for every repository is called master. They just named it master. That is the default branch. When you create a new repository, you're going to have master. When you commit to, it's just a branch. It's just another pointer to a commit. I'm going to go to master. And I'm going to create a new branch. Now remember, head is where I currently am. If I create a new branch, I will create it based on where head currently is. If I had created a branch at v1.0, it's very different than if I create a branch at master. We'll see that in a commit graph that I'm about to show, but let me set it up first. So I'm going to check out a new branch. -b, and I'm going to call it bug1. Branches are so easy to make that I'm going to make a branch to fix this bug. I have not changed master, nor have I committed anything. Master and bug1 both point to the same commit. But because I've checked out bug1, when I commit, it's going to advance bug1's pointer, but it will not advance master's pointer. Again, this will become very apparent in the commit graph. If I do a git log, I'm going to see that I fixed bug1. If I go do a log on master, there is no bug fix 1 because master doesn't have that commit yet. Master points to the commit prior to bug1. So if I git check out master, we're going to see that bug1 fix is not present. Now an urgent situation has come up. Version 1.0, it turns out, has an error in it. It has a bug. I need to go fix it. So I could fix it on master, but master has additional commits that aren't ready to go to production yet. So what needs to happen is I need to check out and make a new branch from version 1. To do that, I'm going to change head to the point that I want the new branch to be started on. Then create a new branch. If I'd created a branch in the previous checkout, then bug2 would have contained all of the fixes, all of the changes, features, whatever, that were on master. I didn't want that, so I had to check out a different commit, then branch. You'll always branch from the current directory, from head. Now that I have this branch, I can create my fix. I can commit it, and I can do whatever is needed to push that commit to production. If I show v1.0, bug fix 2 is not there. If I show master, bug fix 2 is not there. If I show bug fix 1, it's not there. Here's what the commit graph looks like. I'm sorry. Seriously? Oh, premature. Sorry, my bad. Here's the commit graph. I skipped a couple slides, but I went over them anyway. So we had our linear set of commits. I created a tag, the blue pointer there, on one of those commits. After that, we split into two different directions. One direction was master. It was just the linear set. I went back in time and made another branch called bug2. After I had master, I created another branch, and so far it's just a linear set of commits because there's only one, called bug1. As you can see, commits are the actual objects that have the changes in them. Tags and branches are just pointers. There's nothing special about them. In fact, if you go in and look at the .git directory, you will see a place called bug2, and inside of that file is the commit ID. That's literally all it is just a pointer. When working with branches, when you switch between them, it's nice, and I highly recommend that you have a clean working directory. It becomes even more important as you do some of the higher level things, cherry picking, merging, rebasing. It actually requires you to have a clean working directory. A tool to help you do this is called Stash. I'm currently on bug2, and let's say I started working on it. So I have some changes. But now my boss comes to me, he says, look, we need to have this fix on bug 1 immediately. We found another bug. Let's go take care of it. But I say, oh no, I've got I've got my fixes in. I can't really switch right now. I'm in the middle. It's not great. But you can. Git stash save and then give it a message. If I do a status after the stash, my changes are gone. I have a clean working directory. I can switch branches easily. My working directory is still clean. If I look at A, it doesn't have my changes. So where are they? My changes exist in the stash. The stash is just a stack of sets of changes that you have stored there. To show what's in it, git stash list. As items are added, you will see them appear here. To get the items back, because it's a stack, let's say I've fixed my bug now. I'm going to go back to bug 2. Nope, just kidding, bug 1. Bug 1. I'm going to do a git stash pop. It's going to take the most recent stash I did, apply it. If I look at A again, there are my changes. It's very helpful for context switching. If you don't want to commit something just yet because it's broken, whatever, but you do need to switch, use git stash. Merging and rebasing. Potentially the hardest thing that you're going to be doing with source control is working with other people, right? But that's what it's designed for. It should be pretty easy. There are 2 different ways that you can work with other people, that you can incorporate their changes into your changes. One is called merge, the other is called rebase. The difference is that merge will add a merge commit. It will take your commit, it will take your set of commits, their set of commits, it will merge them and create a new merge commit with any changes needed to make it compile or run, or if there were actual conflicts between, it will make a new merge commit. It will have a commit ID. It can be referenced. It can be reverted. Rebase, on the other hand, will not do this. The easiest way to explain rebase is with a commit graph. But basically, it's going to rewrite your history on top of their history. In a merge, this graph up at the top is what we started with. In a merge, I have master and I have bug 1. I want to get master's changes into bug 1. So I check out bug 1. I'm going to be writing to bug 1. I want master's changes on bug 1. So everything happens on head, my current directory. I need to check out bug 1 first. That's where head is. So what I do is I run a command git merge master. What happens, master remains unaffected. Master still points to the same place. Bug 1, however, is advanced to the new commit that merged your changes together. Bug 1 now contains master's changes. Rebase, on the other hand, is a little bit different. Rebase is going to go find the last commit the 2 branches had in common. It's going to remove all your changes since that time. It's going to go to the second branch, master in this case, and then reapply your changes one at a time. As it reapplies them, it's a new commit. It will get a new commit ID. It's way too small, but at the end of each one of those commit IDs, there is a prime. The commit ID is different. It's different commits, and that's important. you no longer have the same set of commits. Each one of them has the same set of contents, but it is a different set of commits altogether. Why this makes a difference, if you look at the second bullet there, in rebasing, sharing requires commit IDs to be similar, identical. It requires the same set of commits. If you and I are working together on the same project and I rebase what we've been working on onto another branch, I can't share with you anymore because Git thinks they're different commits. Even though they have the same content, it will require a merge between you and your coworker to continue working together. The merge is going to be awful because it's the same content. You're going to conflict at every point of the way. So rebasing is really awful when you're trying to share. For that reason, you never rebase master onto anything else. Merging, however, has its own set of problems. Merging cannot be reverted. You can revert the contents, but you cannot revert the history. So if you merge bug 1 in that previous example, if you merge bug 1 into master, you can revert the merge commit, but you can never revert the fact that you have already merged it. If you try to merge it again at a later time, none of your changes will come across. For this reason, I am very careful when I use merging versus rebasing. If I'm sharing, I always use merge. If I'm trying to make a linear set of commits, I always use rebasing. If I'm sharing and want to make a linear set of commits, I wait until the branch is ready to be merged back wherever it goes. I wait until the feature is ready to be released. And then I say, okay, everybody, we're done. No more commits. I rebase, I push it to master, and I'm done. There is one case in which merging is the only option, and that is when you're trying to incorporate a set of changes from a lower branch. If I'm on master and I want to incorporate bug 1, I have to do a merge. There is a thing called a fast forward. It does the same thing. I will show that in just a minute. So let's actually do this and take a look at the log. Ignore this, or rather, let me explain what it does instead. Git reset -- hard. It takes all of your current existing changes and throws them away. It goes back to your last commit. My changes to A are now officially gone forever. I have not stashed them. I have not committed them. They are gone. Now, I'm on master. I'm going to create a commit, a couple commits. To do that, I have a script. It's really simple, and I can't see all of it on my screen. Basically what this commit is going to do, this script, it's going to go and just make a file and commit it. Make a file and commit it. That's all it is, once a second. So I'm going to do that a couple times. There we are. Git log will show I made 3 commits, each with the Unix timestamp. That's all that happened. Each one added a new file, just a way to get commits. Now, if I do git checkout debug fix, what is it, bug 1. Remember that bug 1 is off of master, and it had 1 commit. Darn my poor typing. We fixed the bug on 1, but now it has diverged from master. Somebody else made some changes on master, and now we need to incorporate those changes before we can put our stuff back onto master. You know, test it, make sure it compiles, make sure it runs, run the tests, do whatever we need to do. There are 2 ways. I'm going to create a separate branch for each of the ways. So I have bug 1 checked out so that I can create a new branch from bug 1. I'm going to call this first one M for merge. I'm going to get merge master. This will change the M branch. It will leave bug 1 unaltered. You can see it found the 3 files that master had changed, the 3 commits. It brought them in. If I do a git log, we're going to see a couple things. First, we see a merge commit. As I had said, merging makes a commit. Then we see the 3 files that we had added on master. After that, we see bug 1. But that doesn't really tell us the history of anything as far as branching and merging goes. To do that, I'm going to go to this command I said I'd run again. We can see branch diverged. Some commits were made on one of the branches, some commits were made on the other branch. And then they came back together in a merge. However, if I go back to bug 1 and I make a new branch called rebase, or R, and instead I do a rebase onto master. First, it takes my commit, undoes it, advances to master, and then reapplies my commit. If I do a git log, no merge will happen. Also, we'll see my commit applied after masters. It's now a linear set of commits. No merging, no branching, no weirdness. I find that it's very, very nice to have this sort of a repository, a linear repository. Merges are easier when you do decide to do them. It allows interoperability with SVN if you're doing an SVN bridge. It's just nice all around. Very quickly, now I'm going to explain remotes. I've managed my time very poorly up till this point, and then I will open it up to questions, just a couple before the time ends. A remote is a same repository, a clone elsewhere. When you do git clone something off of GitHub or git.loosechart.com, whatever it is that you're cloning, you will be a new remote will be created automatically for you called origin. Origin is just the place where you cloned. Each remote is just a place where you can find another repository. Each one of these remotes has all of the same commits. It has the same history as the last time you communicated with it. So it has a full list of commits, branches, tags. It may be the case that you and I both cloned from GitHub. Your repository is different because it has your commits and you haven't re-uploaded them and I haven't pulled them down. Whatever it is, each one is different, but the idea is that all of them are the same, or at least have the potential to be the same if you synchronized them. So very quickly, doesn't have to be a server either. I can clone anywhere I'd like. I can show the origin location. There's the push URL, the pull URL. It has all the branches, has all the tags. Does it? Git tag. Has everything. It's an exact clone. Now, as the two become out of date, there are three functions that are helpful. Git fetch will update all the pointers, all the commits. It will download everything so that you know everything about the master, everything about the origin. The other ones are push and pull. Push is a way to upload your changes to the remote. Pull is a way to get those changes down, somebody else's changes. I skipped over the last part because of poor time management. Let me just name these few things here real quick that are interesting and I find daily use for. Cherry picking. It allows you to pull single commits from another branch. It's frequently the case that I will cherry pick, so all of our bug fixes at Lucidchart go to the master branch. We have a production branch. I will frequently cherry pick individual commits to production so that they alone can be pulled up to production. Git bisect is a way to find bugs, is a Git supported binary search on where a bug was introduced. Git add -i, instead of staging entire files, will allow you to stage portions of files. In fact, I never use git add. I always use git add -i. Git merge base will take two branches and find the common commit. For example, in rebasing, uses merge base, takes the two branches, finds the common, reverts, fast forwards, and applies. Git rebase -i will allow you to rewrite history in your own way. Maybe you want to rename a commit. Maybe you want to merge two commits together so that they're exactly one commit. It allows you to do whatever you want as far as the rewriting is concerned. And git blame, if you're looking for who wrote a line of code, it will show you who did it, when they did it, and what it became. I don't think I have time to answer any questions. I do? My clock is ahead here. Sure is. Okay, we'll take one question to begin with. Again, I will be in the back of the room just until Jen's presentation starts. It's likely you'll want to attend that. So, you know.
Is there an easy way to add all modified files to?
There is, and I specifically didn't show it because I hate it.
Can you show it?
It's frequently the case. Sure, it's git add -A. That's all it is, and it will do that. The reason why I hate it is because I frequently will put in debug statements everywhere. I don't want to commit those. That's why the git add -i helps. I can actually, without modifying the file, I can say, yes, I want these fixed lines. No, I do not want the debug statements. Additionally, there is a, just, you know, if you're going quick and dirty, there's a way in git commit, I believe git commit -a, that says commit everything. So you don't even have to add it. Yeah. Oh, sorry, I apologize.
Right. You're doing everything that's from the terminal. Is there any kind of visual tool that you would recommend?
Yeah, so depends on your operating system. Git GUI, it is a command, but I don't have it installed. Oh well. There is Git GUI. There's Git K if you're in Windows. I believe that there's even a Tortoise Git if you're familiar with Tortoise SVN. I never use those because they lack all of the command line sophistication that I require. But, I mean, for anybody else, they're probably good, and there are a lot of people at Lucidchart that use it.
Before I ask my question, there is a Git Windows GUI that Git provides and gives you a command line also. But on stash pop, is it smart enough to know which branch you're on to pop the stash from that branch, or if you pop on bug 1, or git stash on bug 1, and then pop that on master, will it apply those changes to master?
It will apply the changes to master.
Is there a way to pull not the first
Yeah.
in the stash?
There's a git stash apply, and then you give it the stash ID, which is stash or at, and then it's just the ID in there. There is a way to do it. The git stash pop or apply will both be very intelligent about what they're applying. It may be the case that after a git stash pop, you have a conflict, and you have to resolve the conflict. But it will apply to whatever you want it to. In fact, I've had that happen where I started work on the wrong branch. I wasn't paying attention, and so I did a git stash, checked out the correct branch, git stash apply, or git stash pop, and my changes were there in the right place.
Okay, cool. Thank you.
How are we doing on time? My clock is wrong, so. Oh, and a little bit of, yeah.
When should you clone versus branch?
Cloning is good for copying a repository. There are two ways to create a repository. First is git init. The second is git clone. If a repository already exists on GitHub or your corporate website or whatever, then you're going to want to use git clone. If you're starting from scratch, you'll want to use git init. Branching is unrelated to that. If you have a repository and you want to start a branch to fix a feature or make a feature, fix a bug, test something, go do whatever you want, that's the time to use branching. Does that answer your question? Great.
When there are two versions of a file to be merged that can't automatically be merged, my understanding is that the typical way to do this
Yeah, sorry.
is with a git diff. And my experience of using diff at the command line is that it provides a couple of different formats, neither of which is terribly useful. And my preferred mode is inside Emacs to use compare windows, which works beautifully, but it requires both the files to exist in the file system so it can open them up as files. Is there some way to get both two different versions of the same file into the file system without hexadecimal names, so that we can find them and do compare windows?
Yeah. In fact, let me show that, and this will be the last question I answer here. So I've got to move out of the way. I apologize, Jen. At any point, any time, you can say, I want a file, but I want it from this commit. So let's say I want the very first version of A. I can do git checkout, give it the name of the commit. It could be a tag, branch, whatever. And then give it the file. And I believe you can also, no, you can't. You can check it out. This will give me A as it existed in the first version. I can move that to another, A.old, and then do git. So right now, I think A has changed, right? Yeah. So if I do git checkout head A, what it was the last commit I made, and then move A to A.new, I can see the diff. So that's a nice way to pull out previous versions of the file. Thanks for your time. That's it.